All right, so how's it going? How's it going? So this is topic 3 notes. Now, before we go into actually going over the notes, let me just say this video is a little long, but I have to kind of go everything kind of detail so you guys understand what I'm talking about. Before we do that, I need to introduce this here to you. This is called the vertex form of a quadratic function, right? So here's your a value, here's your h, and here's your k. So this is called vertex form. Remember, this is the parent function right here, y equals x squared. All right, so let's go ahead and get into it. So today we're doing transformations of quadratic functions. So basically, when I add or do something to this x squared, right? When I add or subtract or put something in the parentheses like I did here, what happens to the picture, my graph? What happens to my graph? So that's what we're trying to figure out today. So here's what I want to show you today. When do you have a reflection over the x-axis? Well, you have a reflection over the x-axis when you have a negative in front of your function. And it's more specifically, it's where it's outside of a parentheses. I'll show you an example in a minute of the difference between something where you have a negative being multiplied outside of the parentheses or inside the parentheses. So this is what your parent function would look like here, right? So you would have y equals x squared, and that's your parent function. Now, your function when you have negative, or y equals negative x squared, all right, it would look just like this. It reflects over the x-axis, all right? And that is as easy as that one gets. So we have over the x-axis, and then we have a reflection over the y-axis, okay? Now, the thing about the y-axis, it's exactly what I have written here. Unnoticeable when the axis of symmetry is 0. So if it was right here, right, and I reflect it over the y-axis, what happens is it looks the same, right? It's going to be the same shape. It's going to be, so you can't really tell that it's reflected. But it's noticeable when the vertex is not at the origin. So I've given some random parabola here. What I'm trying to show you is that this is just a quadratic function here, and if I was to reflect it over the y-axis is right here. If I was to reflect it over the y-axis, what would it look like? It would be somewhere over here. Still U-shaped parabola, and then this would be its reflection. Now, how do you know when it's over the y-axis? When it looks like this, when you have a negative inside of your parentheses. So again, I'll show you examples later on, or actually I can show you right up here. When you have a negative, when you have something written out like this in vertex form, when you have a negative out here, that is going to be over the x-axis. But when you have this parentheses and your negative inside next to the x, that's when you're going to have the y-axis, a reflection of the y-axis. All right, 2 down, 4 to go. So we have this thing called a vertical stretch or compression. Now, the easiest thing to think about this is a rubber band. So let's say I had this rubber band. It was out, if I was to stretch this rubber band vertically, right? So vertically would mean you have to grab the top and the bottom, and I'd stretch it this way and stretch it that way. What would happen to the graph? Or what happened to this rubber band? Right, it would become more narrow. This rubber band, if I was to pull it, it would become more narrow. That's the reason why a vertical stretch means narrow. Now, vice versa, let's say I had this rubber band and I was to compress it vertically, meaning pushing it down this way and up that way, what would happen? It'd become wider. So then your graph would look something like that. So how does that help us? So we have to know the difference between having a vertical stretch or a vertical compression. Now, when do we have one of those? Right here. When your a value, so this, getting off track. When this value right here is greater than 1, so 2, 3, all the way to infinity, right? When this value right here is greater than 1, that's when you're going to have a more narrow graph. And when that a value is, it's a number in between 0 and 1, so like 1/2, 0.75, any of those values, that's when you're going to have a wider graph. So I'm just going to draw you a rough picture just so you guys can see. So let's just say this is my parent function, y equals x squared. So a more narrow graph would look like this. All right. Now, if it's a more narrow graph, your a value in front has to be greater than 1. So I'm just going to make something up and say let's say 3x squared. Okay. And then let me draw another graph. Let's say I had one that's wider here and here. Okay, since it's wider, your a value must be less than 1, greater than 0, say 1/2 x squared. Okay, so there are two different graphs right there. So we have a vertical stretch and we have a vertical compression. All right, moving on to this one. Here is a horizontal stretch and compression. Now they're very similar in the fact that a fraction or a decimal, sorry, something, a value between 0 and 1 will still make it wider, and a value greater than 1 will still make it more narrow. So what's the difference? Well, remember the first one I was like, say we have a rubber band and I'm grabbing it from the top and the bottom and I'm pulling away or pulling towards, right? Now a horizontal stretch and compression is exactly what it sounds. You're gonna grab the two sides right here, and then if you stretch it horizontally, right, what happens to it? It's gonna become wider. All right, and then again, let's say if I have a rubber band and I grab it here, and I compress it, right, push it in this way, what's gonna happen to it? It's gonna become more narrow like this. So that's why we have two different things, and then there's a difference in it. So when we have that a value being multiplied outside of your function, that's a vertical stretch or compression. When you have that b value inside of the parentheses, that's when you have a horizontal stretch or compression. So let's go ahead and draw some examples real quick. Again, let's start with the parent function. Remember, the parent function is just a parabola like this. Let's call that y equals x squared. Now let me draw a function that is more narrow. We'll say here and here. Now this is what it would look like. I'm just giving you an example of what it would look like for a horizontal stretch. Y equals, I'll do a parentheses, let's say 5x, close that parentheses, squared. Okay, so the difference is one is in the parentheses and one is not. All right, so then let me draw an example of a more wider parabola. Bam. So an example of this would be, let's say y equals, or f of x equals, let's say 0.75x squared. Bam. So those are examples of a horizontal stretch and compression. All right, lastly, let's go down here. We have something called a horizontal translation. Basically, it's moving your graph left to right. And then we have a vertical translation, which basically moves your graph up and down. So let's go over this one first. Now, in these notes right here, on your notes you have C, but I want you to change it to H just so that we can stay consistent with the vertex formula. So if your H value, meaning if you're inside of a parentheses and you're adding something to it, what's going to happen is it's going to move your graph, right? So let's say this is your graph right here. Or actually, I'll do this actually. Let me go ahead and draw my parent function because we know that's going to be right here, right? Y equals x squared. All right, so let's say we change, so let's say I'm adding something inside the parentheses. If I'm adding, it's going to move it left. It's the opposite of what you normally would think, right? So then it's going to move left, left, left. Now let's say I'm not adding something, I'm actually subtracting something inside the parentheses. It's going to make it move right, right? Okay, so then here is, let's go and draw two examples of what that would look like. Actually, I can pull something up real quick so you guys can see. Here, here. All right, so let's do horizontal shift. Now, what I want you to notice is when I play this and I turn it on, so that red one is the parent function. All right, so I turned on my horizontal shift. I'm going to play it so you see what's happening. You see my b value is positive, but it's moving left. Now, as my b value becomes negative, right, it's moving right. So that's what happens in a horizontal translation. All right, press pause. Let's go over. Oops, sorry. Here we go. All right, so then we can just draw two of them. Let's just say we have one on the right side, okay? And then I'm just gonna make up a random example. Let's call that x, if it's going right, we're subtracting, right? So minus 3 squared, so it's just a random example. And let's draw one on the left side. It should be the same size. Both of my, all three of them are different sizes, but they should all be consistent because we're not actually stretching it at all. And this one right here, let's just call that y equals parentheses x plus 3 squared. All right, so then when you're adding inside of a parentheses, you know you're gonna be moving left. When you're subtracting, you'll be moving right. All right, last one. Vertical translation, where basically you're shifting up and down. This is probably the most easiest to get, or the most easiest to understand, aside from the negatives. When you're adding outside the parentheses, you're just moving up. And when you're subtracting, you're just moving down. So I'll just go ahead and draw that real quick because that's probably the easiest to understand. At least to me it is. Let's call this y equals x squared. That's the parent function. And let's draw a graph that's higher, same shape. I'll call this y equals x squared. Let's call that plus 5. and I'll draw one below it. And that's going to be y equals x squared minus, I'll call it minus 5. Bam. All right, so let's go ahead and show you this, what it looks like on Desmos. All right, so I'll close this one, vertical shift, turn that bad boy on. Oops, I didn't turn the other one on. Sorry, my bad. Close that, bam, here we go, play. All right, see, negative values bring it down, positive values bring it up, and it's exactly what you would normally think, right? Negative values usually go down or left, positive values go right and up. All righty, so that concludes our notes. But I want to do a few examples before we go so you guys kind of understand how to use this kind of like cheat sheet, these little notes for you. So stay with me. All right, so here's how we do this. Let me go ahead and erase these real quick so we can kind of understand them. I'm only going to do 2 of them. So let's look at an easy example right here. Let's say I'm looking at 10. And I'm saying, okay, my parent function is y equals x squared. What changed? Oh, now I'm multiplying 3/4 to my x squared. Let me go back and I'm going to compare this picture to everything that I have highlighted to see what does this look like. So I have 3/4 being multiplied. Right here I have addition, or subtraction, addition, subtraction. It does not look like a vertical translation or a horizontal translation. Oh, right here, like I have multiplication. This one shows me something that's being multiplied outside of a parentheses, and this shows me something inside. Is there any parentheses here? Nope. So that must mean it looks like this. It must be a vertical stretch or compression. Now I have to compare. So what I'm multiplying is a number that's in between 0 and 1, right? It's 0.75, which means I have a vertical compression, All right, so then that's what you would say. You would say, if you're describing the transformation, you would say vertical compression, right? Vertical compression by scale factor of whatever the value is to be multiplied, scale factor of 3/4. Bam. That's it. That's describing the transformation. Let's do one more, a little more tricky. So here we go. So remember, if my original parent function is y equals x squared, what changed? So this, oops, that's too big. All right, so I have this 6 being multiplied on the outside, right? I have this negative being multiplied on the inside, and then I have this +1 being added on the outside. So I have 3 transformations that's happening. I need to list all 3 of them. For me, the easiest one to always go and see is the very end, because that's either moving it up or down, right? Because we just went over that. If I'm adding, I'm moving up. If I'm subtracting, I'm moving down. Since I'm adding 1, that means my transformation is, so say moves up 1 unit. Bam, easy. All right, so then we have a negative inside my parentheses. The only time I'm dealing with negatives is the very top of this cheat sheet, right? So if I'm multiplying by a negative in the outside of the parentheses, that's a reflection over x. But if I'm multiplying with a negative in the inside, that's a reflection over y. So that means I must have a reflection over the y-axis. All right, so we say reflect over y-axis. Lastly, what does it mean to have a 6 being multiplied on the outside of a parentheses? We actually just did that one, right? It's a vertical stretch or compression. If it's 6 does not fit here, but it does fit here. That makes a true statement. So it must be a vertical stretch by a scale factor of 6. All right, so vertical stretch, right, by a scale factor of 6. There, just like that. All right, so I'm gonna do one more showing you the how do we work backwards, and then that's it, guys. That's it. All right, so let's say here they're giving us a description of what's happening, and we need to come up with the actual function, right? We need to make it look like this or something like that. How do we do that? So let's see. Remember, my original parent function is y equals x squared. So how do I change this so that it shows that I've shifted 4 units to the left and 9 units up? Here's how you would do it. So we know that 4 units to the left, what does that look back? Go back to my cheat sheet. If I'm moving left, it has to look something like this, right? Where I'm adding or subtracting inside, but because I'm moving left, I actually have to add whatever value they give me. What does it say? Moving 4 units left, so then I'm gonna do y equals, parentheses, x plus 4 squared. That shows that I'm moving left, but I also have to show that I'm moving up 9 units. Moving up 9 units, this is shifting up. To show that I'm moving up, I have to just add that value on the end. So then here I go, plus 9. So there goes your, oops, that's not a good color. All right, so here goes your quadratic function there if you were to shift 4 units to the left and 9 units up. All right, that completes your topic 3 notes.